Hello aspirants, welcome to UpSmart. So in this physics class, we are going to discuss the electricity. We will go and discuss the key concept of the electricity, as well as some component, okay, and some basic formulas that are the important from the perspective of your examination. Okay, so when it comes to electricity, okay. So when it comes to electricity, what do we need to understand here? Okay, electricity. What is electricity? That is, in simple word, what we call it electricity. It is a flow of charge. Okay, it is a flow of charge. It is flow of charge per unit time. Okay, within particular unit time. Okay, per se 1 minute. How many electrons can flow? Okay, that is nothing but electricity. Okay, or we can also call it a rate of flow of electric charge. The rate of flow. Okay, rate of flow. How much electric or electrons are flowing within particular time. Okay, this is nothing but both formulas are the same. Okay, or alternatively also we can call it amount of charge flowing through the particular area. Okay, so two things are important. Either we can say in terms of time, or either we can say in terms of area. Okay, so when it comes to the time, we can say we can measure how many electrons, okay, that are flowing within particular time or per unit time. Or when it comes to the area, what we say, amount of charge flowing through the particular area. Okay, amount of the particular area means what? We mostly consider it as a wire. Okay, within that particular wire, how much what amount of charge is flowing. Okay, so what is this electric? We denote it as a I and Q as a flow. Okay, so that is what it is, a formula. Next is the, when it comes to amount of charge, okay, amount of charge, electric charge in time. So how we do this? The I is nothing but current, the flow, and divided by time. So what is it denotes? We are calculating electricity based on the flow, the amount of flow within particular time, okay, or unit time. So this is the formula when we calculate current based on the time parameter. Okay, next is the, what is the SI unit of electricity that we use? That is ampere. Okay, we use ampere. Then these are the conversions. Okay, what is 1 milliampere? Okay, and what is 1 microampere? Okay, next, the direction convention. Okay, this is established before electricity discovered. Okay, believe that positive charge move. So before electricity discovery of the electricity, what was the convention that was established? That the direction of positive charge movement. Okay, so the electrons, okay, the electrons that moves it to in the positive direction, or the positive charges, okay, that positive charges that present in the atom that moves. Okay, that was a conventional. But what is the actual electric flow? What is actual electric flow? That is the negative electrons. Okay, previously what we were considering, that the positive electrons, okay, positive electrons moves, but what is the actuality? In reality, it is negative electrons, not a positive charge that flow. It is negative electrons that flows. Okay, they are the actual carrier of the current. Okay, so this is the basic of the electricity. Next, that we'll see through the some formulas. So through the three definition, what we can conclude, it is a electricity is a physical phenomena, because we can calculate it. It is physical phenomena, we can calculate it. Then it is associated with presence and the flow of electric charge, associated with the presence and flow of electric charge. It is nothing but electricity. Now when it comes to the charge, okay, when it comes to the charge, where we see the charge? We see the charge in atom. Okay, we see the charge in atom. When it comes to atom, there will be positive charge, there will be negative charge, and there will be neutral charge. Three types of charge that we found in atom. Okay, next, the interaction. Okay, how it interact? Like charges repels and unlike charges attracts. So these are like charges, meaning positive. Okay, like charges means two equal similar charges. Okay, consider positive charges. Okay, both are positive. What they do? They will go away from each other, means they repel. Then next, unlike charges means positive and negative. Okay, unlike charges, they are not they are not alike. Then what happens? This positive and negative charge, they attract each other. Okay, so this is the property. Then what is the SI unit that we see when we calculate charge? That is a coulomb. Okay, this is coulomb, that where we calculate the charge. So this is what you need to know about the charge. Okay, basically what is the charge? It is a property of atom. Atom has the three charges: positive, negative and neutral. Okay, when it comes to the interaction, there are two types of charge: unlike charge and the like charge. When it comes to unlike charge, there are the two different charges involved. Suppose positive and negative. Okay, then positive charge involves, they are nothing but unlike charge, like charge. Okay, and what happens in like charge? They repel, they move from each other. Okay, then when it comes to the unlike charge, when two different charges, positive and negative, okay, they attract each other, that we call unlike charge. Okay. So next is a electric current. So what is electric current? It is a flow of electric charge. That charge we have seen here. Okay, that is when the charges flows, that what nothing but electric current. So electric current nothing but the flow of the electric charges. Okay, next, electric current is carried by a moving electron through a conductor. So this is the conductor, okay, which carries the all the electric charges. Okay, these are moving electrons. You can see these are the nothing but moving electrons within the conductor. Okay, next is a electric circuit. What is electric circuit? It is a continuous closed pathway that allow electric current. Okay, electric current means flow of electrons, which allows the flow of electron to travel from power source through the various devices and back to the source. Okay, electric circuit means it is a closed loop. Okay, which facilitate the flow of electrons or flow of the charges. Okay, from the source to again to various devices, again back to the source. Okay, so that's why we use two kind of wire. Okay, this is nothing but some simple example of electric current circuit. Next is a atom. Okay, so that we have seen. Okay, where we found the charge within an atom. Okay, when it comes to the atom, so within the nucleus of the atom, what we do, what we find? The proton. The proton is nothing but positively charged, and neutron nothing. They are nothing but neutral charge. Okay, where we found the proton and neutron, we found at a nucleus of atom. So when it comes to proton, they are positively charged. They found in nucleus, and what is the charge value? That is, they have positive charge value 1.6 into 10 raised to minus 19 coulombs. Okay, then next, neutron. When it comes to neutron, they are the neutral charge and they are found in nucleus. Now the neutron don't have any value because they are the neutral. Okay, they are neither positive nor negative. Okay, they are the neutral. Next, electron nothing. What is the electron? They are the negatively charged. Electrons are the negatively charged. Where we found the electrons at electron shell. Okay, these are the electrons. Okay, we are found them on this electrical shell. Okay, and what is the charge value? The same value that is of proton. Okay, proton has a positive 1.6 into 10 raised to minus 19, but electron has a minus 1.6 into 10 raised to minus 19. Okay, that is the difference. Next is the okay, so this is the nucleus where we see the proton and the neutron. Neutron has a zero charge, proton has the positive, and electrons, where we found electrons, we found at a electron shell. Okay, electron shell at the outer part of atom we found. In nucleus only we found either proton and the neutron. Okay, and electron, when comes to the, we found it on shell. Okay, that is what we need to remember here. Okay, based on this we'll study the electricity. Now this is a simple explanation of how electricity exactly works, how it works. So that we have seen, electricity is physical phenomena which facilitate the flow of the electrons. Okay, so what flows? It is an electrons. Okay, negatively charged. Okay, negative charge that flows. Okay, that is what, nothing but electricity. Now in atomic level, what happens? We have seen at nucleus there will be proton and the neutron. At the shell level, Okay, what will be there? Electron. So this electron dislodges and they move from one atom to another. So these electrons that are based on the electron shell, okay, what happens? They leaves this particular atom and they move towards the different atom. So they leaves this one atom and move towards the different atom. So same happens. This atom, they will move from the next atom. Then again, electron from this atom, they will move towards the next atom. This cycle continues. And when this cycle continues, so what happens? There will be continuous flow of these electrons. This continuous flow of electrons, nothing but electric current. So electrons, what is the electron? The negative charge that present on the electron shell, okay, that they dislodge the present atom and they move towards the next atom. Same happens with the next atom, okay, it moves to the electrons in that atom moves to the next atom. So what happens finally? There will be continuous flow of electrons. So you can see there is a continuous flow of these electrons. This continuous flow of electrons that are negatively charged. This is nothing but electric current. Okay, now the circuit. The electron must travel through the closed path, that is called circuit. So circuit is nothing but closed path within which electron flows. Okay. Next is the electricity. What are the core concept of the electricity? When it comes to electricity, there are two types of electricity. First is the static electricity. Now where we build the static electricity? When we rub, okay, on the other surface, okay, usually when we walk, that time what we call, due to friction we generate static electricity. Okay, so there you can see, okay, through the friction, okay, even if you are sitting on one chair, okay, mostly the plastic chair, okay, suddenly you will like feel some impulse there, okay, that is nothing but electrons, okay, due to friction. This electron, there is a electron negative charge it is generating and it is flowing through it, okay, and it is what we call it as static electricity. And where it is found? It found at the surface of an object, okay, that is nothing but static electricity. Second is a current electricity. When it comes to current electricity, what is it? Is controlled and continuous flow of electrons throughout the path, okay, within the circuit. So based on the current electricity, what we built, that is our power, okay, to power our all the electronic appliances, what we use? Current electricity. This is nothing but static, okay, static means for the some movement it is there, we cannot take it within the electric circuit, okay, that is static electricity. So other the key concepts that are associated with electricity, they are, first is the voltage. What is the voltage? It is a force or the pressure that measured in volts, okay, we mostly they call 440 ka jhatka, okay, that is nothing but we are measuring the pressure or the force, okay. And how we measure, in which unit we measure? Unit in measure of SI, volt, okay. Then second is current. So current is nothing but rate of charge flow, okay, the negative charge that are flowing, the rate of this charge, that is nothing but current, okay. And how we measure? We measure it as an ampere. Next, resistance. What is a resistance? It is opposition to current flow. And how we measure? We measure it as in a ohms, okay. We'll see the resistance when we study about the ohms. Next, the direct current. What is direct current? The current that flows in only one direction. Only one direction means it comes from source and it must be utilized. You cannot send it back, okay. Mostly your power banks, okay, what happens? The current that comes from power bank, you will charge the mobile, but it won't happens in reverse direction, but this happens in alternative current, AC current, the current that periodically flows in reverse direction also, okay. So the unused electricity that again goes back to the transformer or towards the source, that is nothing but this AC current, okay. So mostly the home appliances that we use, that based on the AC current, and AC current, the small appliances that we see like power bank, all these things, okay, that based on or your mobile battery, they based on the DC current, okay. Next, is a understanding potential and potential difference. Okay, what is potential and potential difference? So now when it comes to electric potential, what is electric potential? It is the amount of work done in moving a unit positive charge for infinity to a point of in an electric field. Okay, definition is looks very clumsy. Okay, some people might understand it is in a first sight, some might not understand, but to understand this, consider one example. Okay, so there is one building, this is a building. Okay, so anybody has seen the Dedanathan movie, they will be they will understand it properly. So in this building you have kept this water tank. Okay, this is water tank. So now the water is filled here. Okay, water is filled here. So the water is filled at that level. Okay, that pressure, that it is unable to hold the another pressure. Okay, increased pressure or some more pressure. So what will happen? The water that present is there in the water tank, that is waiting to escape from it, waiting to escape from it. Okay, that is nothing but a potential, the potential of water to escape. Okay, that is what it is, electrical potential. Now when it comes to electric potential, it is amount of work done in a moving unit positive charge from infinite to a point of electric field. Okay, now this is infinite, it can generate from the universe, anywhere in universe, but when it comes to the end point, okay, there will be certain point it will come. So it will come within a one electron. Okay, where it will come towards the positive charge, that is nothing but proton. So what is the electrical potential? It is the amount of work done in moving. Okay, the amount of work done means the electric force that is generating anywhere in the universe, that is coming towards the proton. Okay, and total work done that we measure in this period, that is nothing but electrical potential. Okay, it is potential to move. Okay, that is nothing but electric potential. Okay, where how we denote it is, we denote it as based on volt. Okay, so three important thing you need to remember: work done, infinite path, and potential measure. Okay, that is what we study in electric potential. So work done also we have seen there. Okay, in previous lecture. So these are the more or less related only. Next, potential difference. What is potential difference? Okay, so potential difference nothing but where we calculate, okay, amount of work done in moving unit charge from one point to another. Okay, so the potential amount of work done, the capacity to do work. Okay, amount of work done from one point to another point. What is the difference that we measure? It is nothing but potential difference. Okay, suppose this is the potential A point, okay, and this is potential B point. So within the from the potential A and potential B, whatever we will measure, this is nothing but difference in electrical potential. And how we will denote? Delta V. Okay, delta V, VB minus VA. Okay, and always remember it is moved from the high pressure to high electricity towards a low electricity. The difference in electric potential becomes 2 point. Also it is measured in volt. Okay, so this is the simple concept. Two concepts are very simple, nothing to worry about. Just remember the this electricity. Okay, the work done. Okay, that or you can call it the positive. Okay, the positive charge that is originated from anywhere in universe, that is coming towards the positive charge. Okay, fixed positive charge or a fixed proton. Okay, and this is nothing but calculating difference between these two points. Okay, next is the voltmeter and the ammeter. Okay, so what is the voltmeter and ammeter? This comparison you need to know, because for the further discussion we will be using this one. So voltmeter is what it measure. Voltmeter, it is measure potential difference or the voltage. Okay, it measure either potential difference that we have seen, or it measures voltage also. Okay, so internal resistance, that will be higher resistance. So in voltmeter the resistance will be high. Why the resistance will be high? Because it is measuring the voltage, the amount of current, okay, that is flowing, the amount of current or the amount of pressure or force that voltmeter measures. Now what you need to do, high resistance means what? It is resisting, it is now voltmeter. When comes to the understand this first, voltmeter, whenever it comes, we always connect it in a parallel. This is a voltmeter, okay, this is the your appliance, okay, or the your circuit. So whenever we connect the voltmeter, we connect it parallel to the circuit. Why we current parallel to the circuit? Because voltmeter, it does not create alternative path to move the current, okay. Its function is to just measure the amount of current, okay, or amount of force that is flowing in the this particular circuit. Now if voltmeter would have had the low resistance, what would have happened? The current, okay, suppose this is source, the current is coming from this source, it would have taken this alternative path also, okay, because it is not resisting to the current. The resistance, it has low resistance, means it is allowing current to flow. So if it allowing current to flow, means what would have happened? Again the current, it would have been increased. So what is our function, what is our task here? To just measure the flow, okay, just measure the flow. For that we keep it high resistance here. So high resistance means it will resist the flow of current. So even the current is flowing here, okay, current coming towards, it will resist it. So what it will measure? It will measure only the current that is flowing through the circuit, okay. It will not allow the more current to come there, okay. So that is what voltmeter does, okay. So the if you see the cell batteries, okay, that maintain the potential differences, okay, current always flows from the higher to lower potential, okay. This is the principle on which voltmeter works, okay. So cell battery maintains the potential difference, means what? It allows them the positive charge, okay, positive charge from one place to another place. So there are the two different places, okay, because we know these particular batteries, okay, batteries works on the DC current, okay, DC current, what is the DC current? We have seen it won't allow reverse current flow in reverse direction. So what happens? It like last time we have seen about the conservative force, okay, it measures in the 2 points, okay, 2 points irrespective of the path. Same way, what it happens, the only one way flow of current is allowed here. So that time when 2 point we measure the positive charge, flow of positive charge, that nothing but this potential difference here. And this for where we measure in the batteries mostly, because or batteries you can say where we use the DC current, there we measure this potential difference, okay. Next is the ammeter. So ammeter, what ammeter does? It measures the current, and when it measures the current, it has the low resistance. Why it has a low resistance? Because this ammeter always connected in the series. Now this is the series where we have connected ammeter in the series. Within the series we have connected this ammeter. Now what happens? There is a current is flowing this in the within this circuit. Now ammeter, if ammeter would have had the high resistance, what would have happened? The flow of current that is coming here, the ammeter would have resisted, okay, resisted. So the flow of current that is going after the ammeter, that would have reduced. So task of ammeter is what is that? It is just measure the flow of current. To measure the flow of current, what ammeter should do? It should have the low resistance. So it should allow the current that is flowing within the circuit to move forward, okay, to go forward. The electrons that will flowing within the circuit, that should be passed to the ammeter. That's why it has the low resistance, okay. And if it has the low resistance, and again these are the interrelated. Ammeter has the low resistance, that's why we connect it in this within the series, okay. So what would have happened if you would have connected ammeter here? Now ammeter has the low resistance, okay. Now the current that flowing, it would have got the alternative path, okay. This alternative path also would have got. So again it has the low resistance, so it will allow the whatever current will come to flow forward. So what it will, the current would have taken the alternative path and it would have gone to further, and so what would have happened? Short circuit would have been happened. So that's why we this mold the ammeter within the series, okay, or in connected in the series, because it has the low resistance and it is the low resistance, that's why we connect it in the series, okay. These are the interrelated, okay. So that is what we need to know about the difference between ammeter and the voltmeter. Next, see, galvanometer to ammeter and the voltmeter. When this galvanometer, what this galvanometer does, it detects the current. Okay, it detects the whether there is a presence of electric current in a circuit or not. Okay, galvanometer. Okay, so suddenly, like most of the time, this kind of mostly it will be yellow color. So the electrician, they will bring this to check the weather current, or you have the another option, directly touch it. Okay, you will understand whether the current is not, but it is risky. So for that, what we do, we use galvanometer. So what galvanometer does, it detects the presence of electric current in the circuit. Okay, it has the high sensitivity, so it is capable of detecting any small current. Okay, even there is a minimal current, okay, minimum flow of electrons, that the galvanometer will detect. Okay, so the detect direction, it shows the direction in which current is flowing. So it detects the current also, and it shows the direction, okay, to which direction the current is flowing. Now what happens when we convert galvanometer to ammeter? Okay, when we convert galvanometer to ammeter, what happens? It connects low resistance in a parallel. Okay, connects the low resistance in parallel. So when we want to convert a galvanometer to ammeter, what we need to do, we need to connect the low resistance in a parallel. Okay, this is galvanometer. Okay, we have connected low resistance in the parallel to the galvanometer. Why? Because we are allowing movement of current here. Okay, it is detecting current, and we are allowing movement of current. And when it comes to converting galvanometer to voltmeter, okay, converting galvanometer to voltmeter, what we need to do, we need to connect the high resistance in a series. This high resistance in a series, that we need to connect. Okay, because voltmeter, what it will do, it will measure the pressure, okay, or flow of the current. So measure the flow of the current means what we will do, we need to allow the movement, the current to move. So first galvanometer will detect this one. Okay, then what we'll do, will implant this high resistance in the series. Okay, or with the in the series in the circuit. Okay, so what it will do, it will allow the it will resist the flow of current. Okay, it will resist the flow of current because it has a high resistance. Okay, so that is what basic when it comes to the converting galvanometer to ammeter and converting galvanometer to voltmeter. Okay, next is the conductors and insulators. What are the conductors and insulators? So what are the conductors? They are a substance through which electricity can flow. Okay, through this substance electricity can flow. So silver, copper, aluminum. Okay, these all the metal surface are there. And when it comes to non metal alloys, nichronium, okay, manganese and constant. Okay, so these are the metal alloys. So what this to metal and metal alloy does, they facilitate the flow of the current. So that's why they used in the wire. Okay, because it allows the flow of the current. But it not happens with the insulator. What are the insulator? These are the substance which cannot allow the electric flow. Okay, so first is the cotton, mica, rubber, plastic, okay, dry wood, paper, dry air. So these are the substance which resist the flow, or they not allow the current to flow. So that's why whenever we touch electric wires, everything, what we either use the rubber gloves, or we keep the dry wood, okay, and we stand on it. Okay, or we the circuits, okay, that is made up of the plastic, because they even the short circuit happens, the plastic will resist the flow of current. Even the same happens with the wood also. In old days they used wood to build the switches, okay, to implant the switches. That is the purpose, because these are the substance which does not allow the electric flow, and it prevents or protects us in case of the electric short circuit. Okay, next is a electric field. So what is electric field? It is region around the electric charge where the electric force acts on other charge. Okay, so it is a region around an electric charge. So this is the electric charge. Okay, this is the electric charge where electric force acts on other charges. Okay, so there are the other charges. Okay, other charges, what will be other charges? That will be electrons. Now this is the proton, means other charges will be electrons. Now what is happening? This is current are moving. Okay, this is moving, and this is nothing but electrical field. So this is the region, okay, between the two charged, okay, unlike charges which generate this field. Okay, that is nothing but electric field. The field between two unlike charges, that is nothing but electric field. Okay, second is the this first is the electric field from isolated positive charges. Okay, isolated positive charge means this is not connected with any other, this is totally isolated. So what will happen? The field will be outward here. Okay, it will go towards the infinite. Okay, next, electric field from isolated negative charge. Now the isolated negative charge means it is coming from infinite towards the negative charges. Okay, infinite, there can be infinite positive charges present in the universe, and from all the infinite positive charges they might come to this negative charged. Okay, that is when we call it as the electric field from isolated negative charge. And okay, whatever the region it will create, okay, that is nothing but electric field. This is the electric field. Okay, this is the region between two charges. Okay, that is nothing but electric field. Now when come to electric field, how we denote? It is E is equal to F divided by Q. What is E? It is electric field. Okay, F is the electric force and Q is a test charge. Okay, that is the formula of the electrical field. Okay, next, these properties of this electric field. What is the properties of electric field? First property is direction is a tangent to the field line. Now this is the field line. Okay, this is the field line. So direction of the electric field, it will be always tangent. Okay, tangent. So when it will be tangent. So this is the nothing but tangent. Okay, so remember the direction of electric field, it will be always tangent to the field line. Okay, next property, that is field lines start on positive charges and ends on negative charges. Okay, this field line, where it is started on the positive line and where it is ended on the negative line. Okay, this is important thing. Also, when it starts from positive charge, what happens? It can go to infinite, or from this is isolated positive charge. Now when it starts from electric field starts from this positive charge, what can happen? It can go to the infinite. Okay, there are infinite possibility that it will go towards the any electric negative charge. Okay, and same happens when there is a negative, okay, or negative charge, isolated negative charge. What happen? There is infinite possibility. Okay, there is infinite lines, okay, that coming from the positive charge. Okay, so when this is the concept of isolated, when positive charge is isolated, so it can go towards the infinite negative charge, and when negative charge is isolated, there is a infinite possibility that the infinite number of positive charges will be origin to create the field with this isolated negative charge. Okay, next, density is a proportional to electric field strength. Okay, density is proportional to electric field strength means high strength. Okay, high density, this is high density. Okay, this is high density means what will happen? It has a high field strength. Okay, now there is a low density. So low density means low strength. Okay, so it depends on the density. Okay, density of electric field. Okay, if density is high, then strength will be high. If density is low, then the strength will be low. Okay, again, next property is do not form closed loop. Okay, do not form closed loop. What was second property we have seen? The positive line start on positive charge and ends in the negative charge. So always it starts from positive and ends at negative. Okay, start from positive, ends at negative. Closed loop means what? This is positive, it is going and coming back to here, then it will be closed, but this won't happen. It always start from positive and goes toward the negative. Okay, so it is never a closed loop. Okay, and another property, the field line never intersect each other. This field line, they never intersect each other because they are tangent. Okay, they never intersect with each other because their direction is tangent towards the what, the fill line. Okay, that's why they never intersect each other. Next is a Ohm's law. Okay, what is Ohm's law? That we'll see now. Ohm's law, what is, oh sorry, okay, what is Ohm's law? It is the potential difference between the 2 point that is directly proportional to electric current. So potential difference is what, V, and where it is directly proportional to the electric current. Okay, when it will directly proportional, when the temperature is constant and other physical conditions are also constant, that time only it proves that the potential difference is directly proportional to the current. Okay, so this is the formula. The potential difference is directly proportional to the current. Okay, so the current, the why it is directly proportional, because what we have seen, the potential difference. Okay, so potential difference at point A and potential this potential at point B. So now the potential, what is the potential? It is a work done, okay, at this particular point, the capacity of this point to send the electricity towards this point. So there will be always difference. Okay, and we use the low resistance. Okay, so that will, what will happen, the current that flowing from A to B, that will be always equal to the potential difference between the point and point this B, because the current is flowing in same amount. Okay, and that is creating difference there. Okay, that is the what, nothing but Ohm's law. Now when it comes to the Ohm's law, okay, so second is the resistors that we have seen. They can be carbon resistor or wire wound. Okay, these are the resistors, small component that we see in the circuit. Then resistor, these are substance have comparatively high resistance. Okay, high resistance means they allow they limit the flow of the current, okay, or the flow of charge within the circuit. Then rheostat, what is rheostat? They are variable. These are devices used to control the current by varying resistance. So different kind of resistance they will use. So when this slider moves, this is the slider, this is resistor. So when the slider moves to change the active okay, when the slider moves, it changes the active resistance path. Okay, so slider moves the right direction, what will happen, resistance will increase and current will decrease, because resistance increase means resistance is disallowing flow of the current. So when the resistance is increasing means what will happen, the current will decrease. Okay, current will decrease. So same, when we move the slider towards the left side, what will happen, the resistance will get lowered and current will increase. Okay, flow of the current will increase. Okay, so that is what Ohm's law. The next is the conductivity versus resistivity. Now what is the conductivity? Electric conductivity. What is electric conductivity? Is measurement that indicate the capacity of material for carrying out the movement of electric charge. Okay, it is capacity of material. It is capacity of material for carrying out the movement of electrical charge. So how we denote it as denoted as sigma. Okay, so height depends on capacity of material. So it will facilitate the flow of current. Okay, depends on the capacity. And when it comes to the resistivity, it is a specific resistance of specific material, means it will resist the flow of the electric charge. It will resist the movement of electric charge. So it is cross-sectional area, and it depends on the cross-sectional area and the units length, that we'll see in the next slide. Okay, how we denote it as a rho. Okay, so unit is a ohm meter. What is, okay, where it gone? Okay, unit for the resistivity is a ohm meter, and flow position, if you see the flow position, the unit length, okay, the flow position will be same direction. Okay, and the flow opposition will be same direction. Okay, this is the flow opposition because of the material's resistivity. This is the flow opposition. Okay, next that we'll see area and cross section. Okay, So factors that affecting conductor's resistance, okay, that we have seen. Conductor resistance, what are the factors? So first is the area of cross section. The higher the area, the lower the resistance. Why higher the area? Because it will get the more space to flow. So if area is higher, then what will happen? More the flow will be there, because it will get the more space to flow. And in case of it is lower the area, what will happen? The resistance will be high. So what will happen? Lower the area, higher the resistance. Okay, because it is what happens, it will decrease the charges flow opposition. Then next, range of electric conductivity. The metals that we use, the copper, silver, atomic metal, okay, that we have seen. What is the range? 10 raised to minus 9 minus 8 to the 10 raised to minus 6. That is the range of electric resistivity. Okay, now the second is the length of conductor. Depends on length of conductor. Higher the length, higher the resistance. Why higher the length, higher the resistance? Because what will happen? Increased chance of electric collision. Okay, higher the length means there will be increasing chance of electric collision. Okay, so that's why higher the length, higher the resistance. Okay, so higher the resistance. Then lower the length, lower the resistance. Lower the length, lower the resistance. Okay, that is because it will reduce the chance of electron collision. Okay, next, for non-metal, what is the range of electric resistivity? That is the 10 raised to 12 to 10 raised to 17 ohm meter. Okay, that is that for non-metal. And non-metals are mostly insulating, and the metals and alloys are, they are conductive. Okay, so that is difference here. Next is the Joule's law. Okay, this is the last thing we are going to see, this Joule's law. To understand Joule's law, understand this. There are the moving electrons. Okay, there is a moving electrons. Okay, we have seen this initially in atom. The electrons will be moving. So these moving electrons, what will happen? There will be collision with atom. This moving electrons from one atom. Okay, moving electrons from one atom move towards the next atom. So what will happen? Ultimately there will be collision, and this collision, what will happen? It will create the kinetic energy, and this particular energy will be transferred. Okay, this transfer energy will cause increase internal heat and energy. So what will happen? Because of the electrons are moving and their capacity to collision with other atoms, what will happen? It will create the kinetic energy, and the kinetic energy, what will do? It will increase the internal energy and the heat because of the that continuous collision. Okay, what will happen? It will create the internal energy and the internal heat. Okay, and where we use this heat now in desirable function, we intentionally facilitate this collision. Electrical heater, okay, iron, electric fuse. Okay, we intentionally arouse this cohesion. But if this cohesion is happening in the TV, computer, okay, and they are getting heated, then what will happen? Will suffer the losses. It is a undesirable. There is a chances of circuit break or the circuit collision. So that's why there is desirable function where we need to produce heat, where we facilitate the this increase in heat by facilitating collision of atom and electron, and it is undesirable when it comes to the devices where we don't need the heat. Okay, so what is the law? Key relation: the current, the heat that produce, it is directly proportional to square of current. Means the heat it will produce, it will equivalent to double of the current that is flowing in the circuit. Next, the heat proportional to the resistance. So heat proportional to resistance means higher the resistance, higher the heat, lower the resistance, lower the heat. Okay, because what is resistance is doing? It is stopping the flow. It is stopping the flow means what it is doing? It is increasing chances of collision. Okay, it is increasing chances of collision of atoms and electrons, and it is increasing chances of generating kinetic energy, increasing chances of generating internal heat. Okay, that's why higher the resistance, higher the heat. And what next is a heat directly proportional to the time. Okay, because we have seen time, the length example we have seen. Okay, if there is a more length, or it is taking more time to flow the charges are taking more time, then what will happen? The possibility of collision will increase. The possibility of collision increase means what? There is a possibility of generating kinetic energy, internal heat, as well as internal internal energy. Okay, so it depends on, if time is high, more, then heat will be more. Okay, because it will increase the chances of collision. Okay, that is what again it is written in this. Okay, next is the some basic things, okay, that are important to understand. Okay, first is the electric bulb, okay, that we usually see. Electric bulb, who invented? Thomas Alva Edison. Okay, so this person when invented will what the filament that we use, that is the tungsten here. So the melting point of tungsten, how much it is? 3380 degrees Celsius. That is the high melting point it has. Okay, next the energy consumption. Okay, where it will energy come? Most of energy consumed in heating. Okay, energy consumed in heating, because the if you observe whenever you use these filament bulbs, okay, so even if you observe the pin that will we switch in, that will also will get heat and along with the bulb. Okay, so we need to use the non-reactive gases. Why we need to use non-reactive gases? To prevent oxidation and burning out. So what are the non-reactive gases? These are the nitrogen and the argon, or the mixtures, other mixtures that we use to prevent the oxidation. Okay, next electric fuse. Okay, electric fuse, what it does? It protects the circuit. Okay, it stops the flow in overloading and the short circuit. Okay, so if there is an increasing flow of current, so what will happen? This fuse melts. Okay, fuse melts, and what it does? It prevent the short circuit and prevent the appliances there. Okay, and the connection and melting point. Okay, they are always connected in series. Okay, so when it comes to the this fuse, what we do? We always connect it in the series. Okay, so what will happen? There will be low melting point. Then the materials and alloy. Metal alloys. Okay, metal alloy wire. Which metal alloy wire we use in a fuse? That is a tin, copper, aluminum. These are the metal alloy wires that we use in a fuse. Okay, this is what you need to understand about the electricity. So I have covered the basic concepts. Okay, and some logic that you need to understand this concept. So that is what it is very important for the electricity. So next session will come with a new topic, and then we'll discuss that topic also. For today, thank you very much.